Now, the students, today I will start the next topic related to this complex number, that is conjugate of complex number. And students, see what is conjugate of complex number. The conjugate of complex number, that is, let z is the complex number. I have written here a plus iota b. Then conjugate of this is divided by z bar, and that implies a plus of iota whole bar, and can be written as a minus iota b. Means you just change the sign of the terms containing iota. This is the slight difference between additive inverse and conjugate. In case of additive inverse, you have to change the sign of whole the terms of the complex number. In case of conjugate, you just change the sign of the terms containing iota. That is the conjugate of complex number. This conjugate is denoted by z bar. Z bar. What are the properties? There are some properties of conjugate number. You have to remember them. If z is a real number, अगर z कोई रियल नंबर है, then z conjugate z bar, that is z conjugate is equal to z, वो z के बराबर होगा. For example, मैं जैसे ये z कॉम्प्लेक्स नंबर लेता हूँ, that is equal to let 2 plus 5 iota, then it's z bar. Now real, so for real this imaginary part will be 0, so therefore this z will be 2 plus of 0 iota, because this is a real number. 2 is a real number. If properties z is real, only real, the imaginary part is 0, therefore its z bar, its conjugate is again that is 2, so that's why that is z is equal to z bar. This always be real. Okay, now the next is the conjugate of a conjugate is again the same complex number. Conjugate of conjugate, let z is equal to a plus iota b. If I write its conjugate z bar, that will be a minus of iota b. If I take conjugate of this once again, so conjugate of a conjugate, this also changes the sign, that implies z bar is equal to z. So this is the another property, that conjugate of a conjugate is again the same complex number. Okay, let the complex number I taken here, a plus iota b is the complex number. The conjugate of this is a minus iota b. Then conjugate of this conjugate again, that again becomes a plus iota b. So this is the another property of this. And in the next, I have written here z plus z bar. Z plus z bar means conjugate and its the complex number and its conjugate sum is always twice of real. For example, let z is equal to 2 plus 3 iota, and conjugate of this is equal to 2 minus 3 iota. While adding this z plus z bar, that means 2 plus 3 iota and plus of 2 plus minus of 3 iota. By adding this, that implies will be 4. So that is equal to twice of, this is the real part of complex number, that is always twice of real. So this is the property, that is if I add the complex number and its conjugate, then the result always be twice of real object. Or if I subtract, on the same way, if I subtract this, the result will be twice of the imaginary part. That is, if I subtracting here, that z is again complex number, z conjugate is this. If I subtracting this, then this will gives you 6 iota, that is equal to twice of the imaginary part. So that is the another property. And in the next, you see, in the next property I have written is z bar is greater than equal to 0. Means z is equal to a plus iota b, and its conjugate will be a minus iota b. If I multiply z and z bar, that means a plus iota b, when multiplied by a minus iota b, the result will be a square and plus of b square. This always be greater than equal to 0, because a and b are the real numbers, and you know that the squares of the sum of the two reals is always positive. So therefore this is the other property. On the same way, if we having the addition of two complex number, their conjugate becomes z1 bar plus z2 bar. In case of subtraction, you write it as z1 bar minus z2 bar. In case of division, you break the bar. all the terms. So that's why these are the properties of the complex numbers conjugate topic. Okay, so this is the conjugate of complex number. I am taking some questions related to this. The question is, find the conjugate of this. Find the conjugate of, the first question is iota and 5 iota, write its conjugate. And another is, the second part is 1 plus iota and 2 plus iota square, and this whole upon 3 plus 4 iota, and write its conjugate. So these are the two problems to write the conjugate. In first case, this will be written as 3, that is minus of 9 of iota. So this will gives you 3 iota square, because this is iota, this is again 3 iota square, and plus of 5 iota. That implies iota square, that is minus 1. This will be written as 3 plus of 5 iota. So this is the complex number you have written, that is 3 plus of 5 iota is the complex number. Write its conjugate denoted by z bar, that means 3 plus 5 iota and this bar, and will be written as minus 3 and minus of 5 iota. So this is the conjugate of this. Means you have to change the sign of the terms containing iota only. Okay. First of all, write it in the standard form. What is the standard form? That is z is equal to a plus iota b. Then apply the property. Here you have to solve this. That is 1 plus iota is in the one bracket. Second is 4 plus iota square and plus of 4 iota. Okay, that is 3 plus of 4 iota. Now friends, iota square, that is 1. So this term becomes 1 plus iota. This will gives you 3 plus 4 iota. I think it is clear. 3 plus of 4 iota. Now this 3 plus 4 iota cancel. This becomes 1 plus of iota, and this standard form of the complex number z is equal to 1 plus of iota is the standard form of the complex number. See once again, by squaring this, iota square is minus 1, 4 minus 1, that is 3 plus 4 iota. Denominator number cancel, therefore z standard form of this, and conjugate of this is equal to 1 minus of iota. So this is the conjugate of a complex number. Now after that, next I will start with the modulus of complex number. After this conjugate, the modulus of complex number. Modulus of complex number. The modulus of complex number, let z is equal to a plus iota b, and modulus of this is denoted by z mod, absolute value, that is equal to denoted by this, and is defined as the square of real part and plus the square of imaginary part. The square of real part and square of imaginary part, and this having the property that is z bar must be equal to z mod square. Z bar इसके conjugate को complex number से multiply करेंगे तो solve will be z mod square. Why? Let z is equal to a plus iota b. Z bar is equal to a minus iota b. Z and z bar is equal to a square plus of b square, and z mod, this is again a square plus b square under root. By squaring, z mod square is equal to a square plus b square, this whole square, that is this remain this, that implies z bar mod is equal, z conjugate is equal to z mod square. So this is the very important result. You have to remember this. Now in the next lecture I will solve the questions related to this. Now see the one more thing, the representation of complex number. Representation of complex number, how to represent the complex number in a plane. Let this is z is equal to a plus iota b. This is the complex number, and this is the plane, that is x axis, y axis. Now how to represent the complex number? You just put the point, that is a real part, B is the imaginary part, and put the arrow like this and write it as A plus of iota B. So this is the representation of a complex number in a plane. Let this is A, and this is B. Okay, so this is the representation of complex number in a plane, and the plane in which we represent the complex number is called as Argand's plane. आर्गन्स वाज द मैथमेटिशियन, उसने रिजल्ट दिया है और उसका नाम अपने ऊपर रख दिया, दैट इज कॉल्ड एज द आर्गन प्लेन्स, जो एक्सिस सिस्टम वाला होता है। और अगर मैं इसके कॉन्जुगेट को रिप्रेजेंट करूं तो कॉन्जुगेट ऑफ दिस इज इक्वल टू माइनस ऑफ आयटा बी, दिस विल बी हियर, that is minus of iota b, that is the projection of this, that is a minus of iota b, and this is the representation of the conjugate of complex number. So this is the representation of complex number. In the next lecture I will give some more questions to you.